morning. I don't have a ton of time today, but I want to go through a couple things that I started the other day, specifically pixel textures, pixel-based textures generated in Python. And I'm going to show where I made a mistake, and then try to demonstrate how to fix that. So, recall that we were working here inside our Blender scripts. What I had done was I had created an image texture. I had then set it up so that if my example image had not yet been created as an image, I would create it. Otherwise, I would just grab a reference to it. I'd create a float4 buffer inside Blender that corresponded to it. And then I would generate x and y using np.mgrid and set red and blue to be the x and the y, so we would see red and blue varying. And then I would call image pixels for each set on it. Note here that one important thing to note is here I'm switching the height and the width because of the way that it uses row major ordering, but keep in mind that the pixels themselves need to be adjacent to, or the color values themselves need to be adjacent to each other. So even though it's Fortran ordered in that way, or C ordered, Fortran, whatever. Even though it's ordered, row column in that particular way, row column, and then RGBA, the RGBA all need to be adjacent despite that. So let's go ahead and run this script. So got our cube here. Go over on to scripting, execute. Let's see, this was HealFix texture. We execute it. Recall now we've got our image here, example image. It only shows up inside our collection there. It doesn't show up yet in our scene. So now let's go back to geometry nodes, go to cube, new. This is where I got to last time, and I made an embarrassingly simple mistake. So let's subdivide our mesh. We will vector math all of our positions. Then we will set our positions. Our vector math that we're going to do is a normalize. So that will basically turn this into a sphere. Oops. And so there we go. Oh, I forgot to turn on my music. Today I'm going to listen to Oceanator. I'm going to start with Bad Brain Days. And then it's going to go through a couple of the other tracks, including from their new album. All right, so now we've got our sphere. Now what I had done last time, was I had incorrectly set my material. So here, what I hadn't done is I hadn't set my material there. Let's go on over to shading. Takes a moment. My oldish computer doesn't work that well for compiling these shaders. I'm going to do an image texture here. I'm going to draw the color over to base color in our principled BSDF. I'm going to open example image. So now you'll note that so far it doesn't look like anything because, among other things, it isn't yet mapped onto that texture. And this is where I ran into trouble. So let's call this image example. Okay, so that's my cube material. So now let's go back over here to my material set, and we'll call it image example. So now, let's see, my UI isn't quite done enough. So let's turn on material preview. And now all of a sudden, our image is mapped onto it. So, a couple things to note here. This is our boundary, and actually, if I can go over to my shading, along with the dead, another bad brain day. Okay, so here, look at our example image. Let's see, where do I get my, excuse me, sneezing. So we can see what it looks like here. Let's see, how do I make this come up with it? Oh yeah, view, there we go. So here's my example image, zoom out. We can see the boundaries here. See this right here wraps around onto that. And then we've also got some stuff here in the middle. So it is mapping the entire thing onto it. Now, this is a nice little segue into our next spot of stuff. So we are going to now apply some spherical harmonics to it. Okay. Now I will be honest, I learned all my spherical harmonics at one point, and then some later point I ended up always having to look them up when I actually applied them. So I'm going to be doing some of that. So we are going to now create if spherical harmonics, not in bpy.data.images. We are going to redefine width equals 1024, height equals 1024, and we are going to create this. You know what? I'll just go ahead and let it toss that in there. Else, there we go. Now let's import our SciPy special functions. All right. So here our x and y coordinates are actually going to be theta and phi. So it's important to note that we will not be mapping it flat onto our object. What we actually are going to be doing first is we'll first map it flat onto it, and we'll see what it looks like. But then what we're going to do is we're going to apply a secondary, why is that called January 21st? Is that, I mean, that was 2 days ago, but is that actually the name of the track? No. Why is it shuffling? That's odd. Here, I'll just start it over at the beginning. Okay. All right. So what we're actually going to start with is we're going to start with mapping it flat onto the surface, and then we will apply spherical coordinate calculations to it, and then use those as our texture coordinates. So let's see it sort of wrong the first way. And I'm just going to do this sort of the standard way. Theta equals np.mgrid, and we'll do 0 to np.pi, and here I think we want this to be height. Yeah. All right, we'll do that one as well. And actually here, we'll do this in one. Theta phi equals, yeah, here we go. Okay. Now what we're going to do is, let's do, we'll do L equals 3 and M equals 0. And so now we will come up with our spherical harmonics here. This is going to be vals equals SPH harmonics. And then we'll call that L, and then phi theta. And I'm not going to do the real, because I think what I actually want here is yeah, so, and I think this is an example written by Stefan van der Walt, but I gotta check. I'm using the example here. Let's go ahead and we'll do Let's see. Actually, yeah, let's do it. Let's do the real. Okay. So now we'll do array equals np.zeros with height 4. Yep. And now we are not going to do that. What we're going to do is we're going to come up with a we're going to use matplotlib's scalar mappable here so that we don't have to implement our own mapping. We're going to come up with a color map there. So cmap is import matplotlib.pyplot as plt. Cmap equals plt dot get cmap. I guess let's do Viridis. Now, and here I'll put a link to the example that I'm roughly following here. cmap.toRGBA. No, this is not how I would have thought it. Okay, plt.cm.scalarMappable. And we'll do and now later on what I'm going to do is I'm going to show how to import color maps in. Okay. And now we're not going to plot our surface. Instead, this is going to be our image. So array color vals equals that. Now I think I might be able to do, yeah. So let's try that. And now image pixels, yeah. All right, so that's our new image. Let's go back over here and let's take a look at what it looks like. Scripting, reload from disk, rerun, no module named matplotlib. How did I mistype that? Matplotlib. Reload. Oh, I guess I haven't installed matplotlib. We're going to give a shot at that, although it's entirely possible it won't work, in which case I guess we will just import our own. Okay, so cd blender. Now, let's see, 4.4, there we go. Pip install matplotlib. Let's give a shot at it, see how it works. Now, I don't know how the interpreter works in Blender enough to know if I need to actually restart it. Oh, hey, how's it going, Ethan? Yeah, it's one of those days, I think. Just trying to find what I can wherever I can. Let's see if this works. Ooh, it did work. I'm a little bit surprised. Let's go back here to my shading. Is it possible that this just worked? Wow, look at that. All right, so now let's take a look at our example image for spherical harmonics. All right, there we go. Now, I think I did something wrong because I think it should be, I suspect it should be contiguous around this because this should be periodic, but we'll come back to that in just a minute. Maybe not, actually. But we'll come back to that. And in fact, what we'll probably end up doing is we will probably come back to using the meshes in Blender as well from the spherical harmonics. All right, so now we've got our texture in here. So now what we're going to do is we're going to utilize, remember in sphere perturbations, I came up with a spherical coordinates tree that we can apply. So we're going to load up our spherical coordinates tree. Now let's go back to our geometry nodes here, where we've turned our cube into a sphere. And now what we'll do is let's take group spherical coordinates, so positions, and that'll give us our spherical coordinates. And now let's set named attribute. This will be a vector, and we'll call it spherical chords. We'll interpose our geometry there. And so now we've got our spherical coordinates, r, theta, phi. So since our shading here right now is just using a vector that is based on the position on the sphere mapping. Let's take our attribute. We'll take that. It'll give us a vector. And so now, check that out. This doesn't totally work because you'll note that it's repeated. But it's a start. Where'd everything go? How do I scroll back to what's useful? There we go. So one other thing to note is that as we generated our texture here, we mapped it from 0 to pi and 0 to 2 pi. Whereas here in our sphere perturbation spherical coordinates, if we look in our geometry nodes, you'll note that it maps it from negative pi over 2 to pi over 2, and negative pi to pi, and 0 to pi. Did I do that right? You know what, let me give, let's get some statistics. So let's take a look at a viewer. Let's see, how do I, this is always really frustrating. Okay, because I actually just want the, I can't do that. Now let's see, what can I do here? I guess we'll store an attribute, and this time we'll store it on the instance, or on the geometry. So we'll store the range of that. Okay, and now so now if we go down here, I guess it's not really storing it. All right, let's take this and do it on the point. Yeah, that doesn't look right. I think I messed up my spherical coordinate calculation. So let's go ahead and take a look at how those are being done. Spherical coordinates. R is the length of the positions. Yeah, that makes sense. Position is position. Okay, so the arc cosine of z over r. I'm going to check all of this. I always always double check these things because I have a tendency to get some of these things a little bit mixed up. So theta is the arc cosine of z over r. So arc tangent of y over x. And what we need here is we actually need arc tangent 2. So let me dig into spherical coordinates, because this currently is not taking into account any of the signs. So let's do arctan 2. Y over x. Okay, so now it does it correct. All right, so here, let's see, operation arc tan 2 value equals y comma x. And so now my numbers run, they've got a range of pi and 2 pi. Well, not exactly 2 pi, but that's probably a result of the discretization. So let's go back here to geometry nodes. How do I get up out of this? There we go. Okay. Geometry nodes. So now we've got our spherical coordinates. So this one runs 0 to pi. This one runs 0 to pi over 2. And actually, that's not right. Minimum here, so it runs 0 to pi and minus pi to pi. Okay, so let's go on over to our shading. Oops, that's sculpting. I don't know how to sculpt. Shading. We're going to get this, and we are going to map range. Data type vector. There we go. All right. So our from min is going to be 0 to 1. Yeah, there we go. Now this one is going to go 0 to pi. I think it can take pi. Let's find out. Might not. Oh, there it does. Okay, good. And then from negative pi to, oops, negative pi up to pi. Now, the other issue that we're running into is it goes r theta phi, but we actually want to split, we want to separate x, y, z here, and then we want to recombine them so that we can reorder them. We need to swizzle them, as they say. So x So here we go. Now I think that I've got my y and z, or y and x mixed up, but we'll try that in just a second. So let's try z going to x, y going to... So there, that's at the bottom. So that might just be a upside down type thing. And then here, it looks like this looks like it maps to that, but so I think my mapping might be incorrect there. So let's try this again. Getting the stuff right can be a little bit frustrating. The x definitely goes to z. Let's try y to x. and z to y. Let's see what that looks like again. No, that also doesn't really look right for spherical harmonics. So, but I guess that's one step forward. So let's see this. I think this is the right one. But I think we should be able to see it a little bit more clearly if I go up one in the M. Let's go back to Helpix textures. Let's try this one. Yeah, I got a real discontinuity there. Okay, so though, it is clear that what we are now seeing is we are seeing that we can map our coordinates onto r theta phi and then utilize an r theta phi organized map here. Looks like this discontinuity is probably my doing. There might be like a singularity there or something. So one way that we could maybe figure this out. Well, no, why is it not contiguous there? Continuous there. Let's try, instead of repeat, let's try clip. Nope. Mirror. Huh. So that discontinuity is, it's got to be this right here. No, it's not. Look at that. Huh. It only shows up on one side. It's right in the middle of the two blues, so it's got to be this. Well, let's go back to my geometry node. Let's make sure that the XYZs here are right. Wonder why it's... do I want it actually taking the attribute off the geometry? Alright, so spherical coordinate stats. Oh. Yeah, the min... You know what? Let's try instead, because it looks like there's maybe some discretization. So let's instead go back to shading and let's do our statistics here instead. Let's try from max. Let's see what that changes it to. If we drop our... No. Huh. Very strange. Okay. Well, let's give up on that for now because we've got almost where we want it to be. Just this weird discontinuity that I think I can probably address in a later time. And let's go back to the geometry nodes, see how it changes as we increase the resolution. So here we've got our subdivision level, and you see as we increase here, our discontinuity gets smaller and smaller, which is actually what we would expect. We're just running into the imperfections here at this sort of singularity. Some of these points might err on the wrong side of which, part of the axis that they're on. It might be giving us some sort of odd download. So I think we should be okay. You see that this gets closer and closer to our value. Let me go back here to the shading. Let's see what different types of sampling points do we have. Yeah, it's on the geometry. Okay. Now, this is the simplest possible way to get it in there. There are ways to do spherical projections. We are not going to be doing those just now. We're going to be doing our usual way. So, let's get back to where we want it to be. And what we're going to do is we're going to experiment with bump mapping this. I'm not totally sure how well this is going to go. So let's take our bump. Ooh, it's hanging on my system. You can see minor variations here. It is looking a little different. It's not exactly what I'm hoping for, so let's get rid of this. And instead, let's do something simple. We're just going to do a noise texture. We'll feed the factor in as the height. And that might actually cause some real slowdowns. Yeah. So now we've got a bump mapped item here. So let's see, vector. So now we've got a noise texture, spherical harmonic overlaid on it for colors. That's actually getting close to where we want to be. Now I want to note that this bump mapping doesn't precisely do what we might think. It's just a shade. Doesn't seem to catch shadow or things like that. So we'll come back to that at another time. What we're going to do now is we are going to create a new file. And this will be import color maps. We're going to call this import bpi. And what we're going to do is we are going to go through all of the color maps and import them in as high resolution textures. So let's go ahead and create them. Now, there's probably a way to do a one-dimensional texture. What I'm going to do instead is we are going to is, and first here we're going to do pip, and unset Python path. We're going to do pip install CMYT. We're going to install some of my favorite color maps too. So, import numpy as np. And now I can't remember, how do we get, nope, that's not what we want. How do we figure out all the different color maps that are available? It always changes. CMYT dot color maps. No, that's not the one. Yeah, that's our map plotlet. Oh no, that's... Let's see. CMYT.utils. There we go. All right, so let's just import the YT ones for now. For CMap in, I'm sorry, for CMap name in CMYT, import CMYT. CMYT.utils dot CMYT CMaps. If, and now we'll call this CMYT CMap name. Oh, there we go. 256 by 1. We'll do it by 4 just in case. Vals equals np.mgrid 0.0 to 1.0. We'll do, you know what? Yeah, we'll do 256J. This will be 4. I don't like, yeah, there's probably, it's probably just superstition that I always like to have an extra couple pixels, but I guess I do. Else, yeah, there we go. We'll reset them if they don't exist. So now, colors equals vals. No, we can just do vals, I think. Right? So now, image pixels for each set. I think we might need to redo this. This might need to be 4J here and this 256J. So let's give that a shot. Let's go on over into scripting, load up our favorite color maps. CMYT has no attribute get CMYT. Oh yeah, okay. CMYT.get. It's actually cm.get CMap. Reload. CM is not defined. What? Oh yeah, plt.cm. Okay. That's fun. Aha, that's what it is. Get CMap, because it's namespace prefixed. So alright, reload. Expected sequence 4096 got 2048. Oops. For J. Alright, maybe I got my coordinates backwards here. Huh, that's odd. Alright, so let's go back to this. 256, 4. Yep. Sounds a lot like 25 or 624, this song, the Chicago song. No, actually that's not true. The riff sounds similar in some ways. Let's say that. Alpha equals false. Print colors.shape. Let's take a look at that. Vals.shape. Alright, it doesn't print that well. Okay, let's get back here. Height and width. That's what it is. We actually need to call 2RGBA. Let's just go through the whole thing. We'll do everything like we did. All right. CMap equals plt.cm.scalar mappable. CMap equals plt.getCmap. CMap.set clim 0.0 1.0 colors equals CMap 2 RGBA vals. All right, that should, we'll go through it the long way. I'm sure that's the issue here. Still isn't the issue. Okay, one last thing. Let's try. This is so strange. Why is it? Ah, I know why. Because it's okay. All right. As type. No, that's not it. Colors equals CMap as type F4. There we go. Boy. Okay. And now that error comes on line 18, which is this, image pixels for each set. So I've got 256, 4. Now over here, when I did this, alpha equals false, float buffer equals true, okay. So I got the colors, and then here, what I'm doing in this case, array equals np.zeros, width 256, 4, 4, dtype equals F4. So now what we're doing is array equals cmap.toRGBVA. So in no case do we have that. We no longer use colors. Cannot broadcast input from 256, 4 into shape 256, 4, 4. Oh, the 2. Where does that 2 come from? Of course. It's the one. Okay. Of course. We'll do X and Y. Actually, we'll just do vals and nothing. There is equal to that. There we go. All right, now let's take a look at some of these. Oh, boy howdy. So what was happening was I was actually unpacking an M-grid that I shouldn't have been. I want to ignore this part and just have this, but I wasn't. So I was getting 2 values there. Okay, now let's go back and take a look at our new color maps. There, that's green. Algae. Ooh, you know what I'm doing. That's right. Got them backwards. Vals. Broadcasting in the wrong direction. 4,256. Let's go back to my shading. Huh. Well, let's try this. Underscore vals. Well, now it's repeating. So I'm still not getting the exact broadcasting right here. So let's take a look at, if we open this up, import numpy as np, np.mgrid 0.0 to 1.0 256j, 2.0 to 1.0 4j, and we'll call this vals and underscore. So vals goes like that, right? 256 by 4. You know what? Maybe this 4 stuff is the whole problem. So let's get rid of all that. Vals is equal to that. 256 1 4 1 256. Now let's delete all of our images inside our scripting menu so that we don't have mix-ups in that. Delete. Go back to our scripting. Reload. Rerun. Could not broadcast to shape. Aha! And that was on line 19. So here, 19, our broadcasting here doesn't quite work. So we got to add an extra unknown dimension. We run it. Now let's take a look at shading. Actually, I should put an image previewer here, huh? There we go. Look at that, Arbra. Apricity, algae. They're all there. Okay. But I don't actually like them being that high, so we'll do 1. No, you know what? It is better to have them this way. We don't need to do anything else. So now, instead of using, so now let's go back into our shading. And now instead of, well, actually what we can do now is we can apply color maps right inside this. So we have all of our color maps, but it would be nice if they were added to a collection. So let's see how we would do that. If we go back into scripting, we've got our images, new collection. We will put that at the top level. No, I guess we can't. We will rename it. Color maps. So let's go back to here where we create our, when we did our orbits, we dealt with our collections. So we can just link all of our objects there. If it's new, we will link it. Here, if color maps, not in that, we create a new one. And so then here, when we create our new image, we will say cmaps.objects.link image. And that actually should be color maps. If image.name not in color maps.objects. Okay. So now let's go back here. Let's delete all of these and see how that works. Okay, we've got this. Run it. Oh, expected an object type, not an image. Oh, right. How do I do that? How do I link our images? Well, I guess maybe we can't. Is that baking? That's probably baking, something like that. Well, I guess we will do something different then. How do I link this? Well, I guess that's actually not that important to do, so we will ignore that for now. We'll just use those images as they are. Okay. So now the next thing we really want to do is we want to come up with a way to take float attributes that are set on a geometry vertex and then map those into color maps. So let's try doing that. Let's go back to our shader nodes. And let's actually see, is it possible to have, well, let's take a look at what we can do with just color mapping here. Okay. And actually, I'm going to put on something different. The Death of Randy Fitzsimmons by The Hives is what we're going to listen to. I have probably less than half an hour before I got to go. Is my camera still working? It is. All right. So let's start a new scene. Let's take a look at what happens if we've got our geometry nodes here. And let's go open our import color maps. We've got our color maps here. So let's create our geometry nodes. We will subdivide our mesh. We will not subdivide it yet. We will set a material. And then inside our material, let's create a linear mapping. Let's say color map. Let's add a texture, image texture. And now our vector here is going to be just our position. And let's do apricity. No, let's do one that's a little more recognizable. We'll do octarine. Now we will connect our base color. Still nothing. So let's preview our image. We still haven't applied our material, the exact same thing that I had forgotten to do last time. So now if we apply our material, and now let's change this over to preview. And so now we're getting our mapping, okay? But that's not exactly what we want to do. Let's see if we can map this based on some attribute here. So let's just map it based on our position. So you see now it goes 0 to 1, 0 to 1, because our cube is located at the origin. If we look at our attributes here, see it's located at 0 and it goes to 1. So why is it doing the repeating values? Let's do our separate x, y, z, and x becomes our vector. All right, combine x, y, z. We will put our y value, our z value, in as our x value. Actually, that should be the y value, I guess. There we go. So now it should be increasing as we go up. And it is. But what we're seeing is that our image coordinates, oh, you know what I bet it is? I bet our image coordinates run from -0.5 to 0.5. So let's map our range. Map our z value from 0 to 1 to -0.5 to 0.5. Huh, that's fun. Does a clamp, so now we just see 0 to 1 going to -0.5 to 0.5. Oh, that's dusk, not octarine. Okay, let's take a look over at dusk. So, yep, it's setting 0 to be right there, which is at 0.5. And then up here, we never quite get all the way up to the top. So it is shifted by what we would expect. So it clamps. No, it's repeating, huh? 1, countdown to shut down. Oh boy, look at that. It's not doing much of anything. I keep clicking. It's not doing anything. There we go. So why is it looking like that? All right. So here, looks like all my 0 values are wrapping around. So let's try clip. Yeah. So all these values down here, which I believe are between 0.5 and 1, right, are being set to 0. Let's see if I can get my axes back on here. Let's look at this in that way. Let's take a look at layout. Aha, that's why it is. It's because they're, oh, of course, the origin is set to 0. Haha. All right, let's go back over into my geometry nodes and let's offset it by 0.5. Head of hair. Pop, one's a billionaire. All right, so let's see, translate. Translation Z. Okay, and now let's go back to shading. And we map. Let's take a look. So now it's running from 0 to 1. Let's just try doing, yeah, directly there. So our cube is now offset in the Z, but apparently not by enough. Oh. There we go. There we go. Now we've got a perfect color mapped cube. Okay, and now let's go ahead and add an attribute to that. And what this attribute will be the distance. So we'll do a utilities, vector, math. We'll do length, distance from 0 to that. Oh, and let's see what happens if we increase our scale. So far, nothing, because it's doing a smooth interpolation along these faces. So let's take that. We'll store our value here. We'll name it distance. We actually want to feed that geometry in. Okay, so now we've got a new one that's called distance. And, you know, I hate doing this transform of the geometry. So let's instead modify our cube properties. Location x, 0, 0, 0. But that is not the origin, that's the center. So let's do 0 0.5, 0 0.5, 0 0.5. Okay, and actually, yeah, scale, now 0 0.5, 0 0.5, 0 0.5. So now it goes 0 to 1. Okay, so we've got our cube right there. Yeah, it wasn't much of anything. Yeah. So let's take a quick look at our shading. And now we're storing our distance. So instead of doing our position, we will do a named attribute. This will be, I think we just want factor. You might as well tune into Rick Mortis Radio. Geometry, and the attribute is distance. So now let's take a look at it in viewport shading preview. And so now it should be mapping distance into the y coordinate here, but it doesn't look like it's doing that. Or if it is, I'm not noticing it. So let's take a look back in our geometry nodes, see what distance looks like. 1.732. Wow, look at that. They're all identical. Of course they are. Wait, why are they? Now if I go here, so the distance, let's map it 1.0 to 2.0. I thought, yeah, it's a square root of 2, but, or square root of 2 should show up in there, or square root of 3 should show up in there. Okay, let's go back to shading. We'll map the float from 1.1 to 1.7. And so now, look at that. That's beautiful. We've got a color map applied. We're not totally understanding the transform here, so instead what I'm going to do is I'm going to do the center here for the distance so that we can see basically a circumscribed cube. Geometry, read, no, it's not that, it's that doesn't do it. There we go. Okay. So now it's computing to the center of the object. And here we no longer need to do the mapping. Or at least the mapping is different. And I guess I still have some things to learn here. Because what we really... Oh, you know what would be the coolest? We actually want the mean. Here, let's do mean. No, statistics. Attribute statistic. Mean into a vector. There we go. So now the distance runs the minimum. I thought the minimum should be, but I guess it's 1. Doesn't make a lot of sense. The mean position is 0? What? Oh, maybe I need this geometry to be this geometry. Nope. Okay, so we now do, though, have, I guess the minimum distance is 1.5 and the maximum is 1.732, so let's go on over here. Go into shading. There's probably a way to pass arguments into the shading. So we will eventually do that. From minimum 1.5 to maximum 1.72. Oh, you know what? I think I'm... Yeah, there we go. The maximum should be 1.2 or something. Check that out. That's fun. All right, now the last thing we're going to do, because we've basically set up our ability to color map based on these different things, based on stored attributes, is, and let's take a look at this. This geometry going in there, attribute, read named attribute, we'll do distance, going into attribute. The mean distance, why is, that shouldn't be a, that should be a float. 1.2, the minimum is 1, the maximum is 1.7. Isn't that what I put in there? Shading, 1 and 1.7. There we go. All right. Now all we got to do is figure out how to pass attributes in to our geometries, and we are set. Or into our materials. But I think maybe this will be where I stop for just now. We've successfully imported all our color maps. We've looked at how to map things into our into those color maps, do texture sampling to get data values back. The next thing I think we'll probably end up doing is going to be importing through CSV files, and then applying multi-step mappings to get attributes onto color maps. So let's see. One last thing I'm going to do before I sign off is I am going to commit these things. Now, the last thing I forgot to do the other day is I forgot to add my README. So git add README with packages to install. All right, looks like the Spear of Perturbations has a change to it. Bottom, this is on the bottom of the bottom. Okay, heel picks. We will add our heel picks texture, and we will add our import color maps. Add texture creation and color map importing. Well, thanks for joining me. I hope you have a good day today too. Hopefully I'll be back at this again soon. This was a lot of fun. Thanks, Ethan. Have a good day.